All right, so here we going for 5.6? Sure, those are words. All right, here we go. This is the longest done the last four in a row. So, okay. But basically we talking about Hinge theorem in this one. And so basically if we're looking here at the first one, it says compare the given measures. So we want to compare AC to XZ, and we can do that because of the angles opposite them, but only because we have sort of the Hinge theorem happening. In other words, we have a 9 is congruent to 9, 7 is congruent to 7. And so the angles between these congruent sides is the ones we can sort of examine. And so because 119 is bigger than 111, that would make the side opposite that angle, XZ, bigger than AC. So I'm going to say XZ is going to be greater than AC. You can put them in that order if you want. You could put AC is less than XZ. That's fine, but it just says compare them. So I did. Okay. So I'm going to go ahead and mark some other things, right? We have the 8 and the 8. The 6 is part of both these triangles. And so we're trying to now look at these angles. So SRT is this angle we're looking at right here. And this angle right here is QRT. So these angles I can compare based on their opposite, because this is the angle, the hinge angle between the two congruent sides. I can compare it using the third side over here. So this 3 is smaller than this 4. So this angle QRT, so the measure of angle QRT is going to be less than the measure of angle SRT. And again, you could have put SRT as larger, but either way, this angle is bigger because the side opposite of it is bigger. Okay, in this case, we have congruent sides here, and here. So our hinge angles are this 90-degree angle and this 70-degree angle in here. Okay, and so we're trying to compare KL and KN. Well, KL is opposite the 90 degrees, and KN is opposite the 70. So KL is going to be bigger than KN, because 90 is bigger than 70. So we look to opposite those angles. And we can do that because, again, I can't stress enough, only if you have two triangles with two congruent sides and you're sort of comparing the angles between them. All right. So we did actually, this one we did up top. We did this up top as example. So let's look at 6. There's basically 3 things we need to look at here, right? We're looking at, well, the Hinge theorem says, again, we can sort of look at that we know that this 64 is bigger than this 35. Therefore, we know that the x plus 7 is going to be bigger than the 2x minus 15. So I'm going to say x plus 7, 2x minus 5, has to be bigger than 2x minus 5. So now I am going to solve this. I'm going to get x over here. I'm going to add it. We get 12. So we can have x is less than 12, right? I just switched it when I switched sides. So that's one thing. So x has to be less than 12. Okay, it's got to be less than 12. Assuming I did that right. Yeah, I think we're good. Okay, but also we have to know, again, we know that this x plus 7 also has to be bigger than 0, right? We can't have a 0 side or a negative side. So we know that x has to be bigger than negative 7, right? So that's another inequality. But also, we have to know that 2x minus 5, because this is also a side. So this side has to be bigger than 0. So we have to account for all of these. So we get 2x is greater than 5. X is greater than 5 over 2, which is 2.5, right? So it's just basically that, I guess I should do. So these are the 3 that we're looking at. And so, again, the way that I would sort of describe it, and the way to do it is basically think of it as a number line. We just put 12 on here, so 12 is here. We're thinking less than 12. We have a 7 here, or negative 7 here, so it's got to be bigger than negative 7. It's got to be greater than 2.5, so 2.5 is going to be somewhere in here. So it's got to be bigger than 2.5. So where is the spot where all of these where all of these 3 are overlapping? Here and here. Like, this is where we have to sort of write an inequality for, and we can do that by basically saying, oh, well, it's just going to be above 2.5 and less than 12. So in other words, we can just say 2.5 is less than x, which is less than 12. So that is how we would answer this. All right. Didn't give you a lot of room here. My bad. All right. Maybe we can make it up on these. All right, so Hinge theorem here, we have 2 congruent sides, right? We have the reflexive one. And so we know that this angle, DCA, is going to be bigger than BCA because the side opposite of it is going to be bigger. So the 11 is bigger than the 10. So this angle here is going to be, so DCA is going to be bigger than BCA. So the measure of angle, let's do it down below like I did the other ones. The measure of angle DCA is going to be greater than the measure of angle BCA. All right, we have all the sides. Let's try to mark things so it make it easier. We have a 6 there, a 6 there, an 8 there, and an 8 there. Yep, so we're trying to compare this angle, angle H, and angle M, and angle L, I should say. And so we know that, so we're looking at this angle and this angle right here, right? So because 11 is bigger than 10, we know that angle L, or angle KLM, has to be bigger than angle, the measure of angle GHJ. Okay, and then now we have some angle measures here. We have, let's see, this is 21 right here, which matches this one. So in other words, our hinge angles are going to be here, this 47 and this 39. The 47 is bigger, therefore TU is going to be bigger than SV. Okay. So we got to find the range. So we might need some extra room here, but let's see what we can do. Again, the angle that we know is between is going to be here, and which is good. So this 65 is going to be bigger than this 54. So therefore, we know that like this side, this 4z minus 12 is going to be smaller than the 16. So I'm going to write that, right? 4z minus 12 is going to be less than 16. And so I could say 4z is less than 28. So z is less than 7. Okay. So good, right? Because it's going to be less than that, right? Right? Does that make sense? Yeah, cool. Because this is smaller, so that's going to be bigger. And then what we also know is that this side has to be bigger than 0, right? So the other one would be that 4z minus 12 has to be, sorry, I meant greater than 0. Has to be bigger than 0, so 4z has to be greater than 12, so z has to be greater than 3. And now in this case, I only have 2, right? So if I did a number line, it would be super easy because it would be 7. It's got to be less than 7. It has to be bigger than 3. So where they overlap is between 3 and 7. But I only have 2 numbers in this case, and I don't have to really think about anything else in this particular case. So I just combine them and just say that basically z has to be between 3 and 7. So 3 is less than z, which is less than 7. Okay, so now we have this angle here. We have these sides are congruent. This side is going to be congruent. So here are sort of hinge angles here I'm looking at. I don't know which one's bigger, but actually I do know this one. I know 72 is going to be bigger than this angle because the opposite side is 30 and the opposite side is 19. So this one, because it's 30, is bigger than 19. So the 72 is going to be bigger than 2z minus 7. Or in other words, 2z plus 7 is going to be less than 72. So 2z is less than 65. So z is going to be less than 32.5. Okay, but remember, also we need to know 2 other things, and that would be that we know 2z plus 7 is an angle. Right, we know 2z plus 7 is an angle, and so it has to be bigger than 0. Okay, so 2z has to be greater than -7. So z has to be greater than -7/2, which is -3.5. Okay. All right. And then also, finally, we know that because it's an angle, it has to be less than 180. So 2z plus 7 has to be less than 180. It's an angle in a triangle, I should say. So 2z 173. So z is going to be less than, and this is not going to matter really as much as 173/2. I'm just going to leave it for now. But those are the 3 that I have to look at. And again, based on my number line that I do, and we can sort of get our answer here. All right, we know 173/2 is going to be above 32. So we know it's going to be like here. This is going to be like 170. This is going to be our biggest number over 2, right? Because it's going to be about half of 170, right? Well, half of it's going to be 80 something, right? So that's fine. And then we have, so we say less than that. And then we have less than 32.5. So less than that. And then we have greater than -7/2, so -7/2, so greater than that. So where they all overlap between here and here. So basically, z has to be between -7/2 and 32.5. I should probably have made that 3.5, -3.5. It might have made it easier, but whatever. I mixed it, so whatever. It's all good. Okay. All right, so finally, we got a hinge theorem going on. We go, this is 90, and that's 122. So 122 is going to be bigger than 90. So so z plus 11 has to be, because that side, z plus 11, has to be bigger than for z minus 6. And so we can get 3z 7 is minus 6, yeah, so 17. So we have z, we divide by 3, we get 17/3, which is going to be 5.6, I think, or somewhere around that. And I do that so that I know generally where it is. Okay, but I would use the exact number. 17/3 is fine. But again, just to get an idea of where it is, sort of in sort of a decimal. All right, and then this isn't it, because we also know that z plus 11, that is a length, so that's a side, I should say. So it has to be bigger than 0. So z has to be bigger than -11. But also, we know that 4z minus 6 has to be bigger than 0 as well, because that's also a side. So 4z has to be bigger than 6. So z has to be bigger than 3/2 when you simplify it. Okay, so now we're thinking, okay, we know that we have our number line here. We know -11 will be here, so it's got to be bigger than -11. It's got to be bigger than 3/2, which is 1.5, so it's going to be there, bigger there. Also, we know that 17/3, like I said, was about 6, so we know it's going to be over here. It's got to be bigger than 17/3 as well. Did I mess up here? Oh, this is different. It's not bigger. This is the other way. So in other words, 17/3 has to be greater than z. So I can flip this and just say z is less than 17/3, right? So again, to make it a little bit, everything's the variables on the left easier for me to read anyway. They're the same thing. So that would make it, so 17/3 is here. So anything to the left of it, right? So our range, again, I'll just highlight it to show us, our range is between these two. So like our range of values is sort of here on the number line, which again is going to be, so we're saying between 3/2 and 17/3. So 3/2 has to be less than z, which is less than 17/3. So that is our answer there. And again, just to sort of show you what our final sort of answer that we would put on all these be here. All right, so at least we're done with those. Yes, not a whole lot of space. I'm aware. All right, calm down, everyone. All right, so now we look here. We have some hinge theorem going on and some other things, right? So we know that these are all congruent. So that's going to affect that. Means we know that these angles are going to be, that these two angles are going to be congruent, and these two angles are going to be congruent. But we don't necessarily know that these will be congruent. In fact, we know that they're not going to be congruent because they're not congruent triangles. But either way, so QRP is this angle, and we're comparing it to SRP, which is this angle. Now, these are congruent, right? These are our congruent sides, and so are these. So these are our hinge ones. So if I look, opposite of this is 5.1, so that's going to be smaller than 5.4. So QRP is going to be less than SRP. QPR is this angle, and we're comparing it to QRP. So comparing this angle to this angle, well P is opposite 8, and QPR is opposite 8, and QRP is opposite 5.1. So QPR is going to be greater than that because the side opposite is bigger. PRS is going to be this angle, and RSP is this angle. So this is going to be across from 8, and this is going to be across from 5.4. So we know that PRS is going to be smaller or less than RSP. RSP and RPS. So these two angles are going to be equal, right? RSP, yeah, because again, those are from our isosceles triangle. QPR and RQPR and RPS. So these two angles here are what we're trying to compare. Okay. Now, in this case, right, we're comparing these two angles, so we can't really look at the sides, right, the opposite sides, because we're, so because the opposite sides, they're both opposite 8, right? So they're both opposite 8. So it's we can't just directly say, oh, they're both opposite 8, so they're going to be congruent because they're not part of the same triangle. And again, R, P, S, yeah, just making sure, and then Q, P, R, yeah. So these two angles. But what we can do is kind of think, okay, so we know that this side is 8 and this side is 8. So if this is 5.1, that would make this angle, we already know that this angle right here is smaller than this angle right here. Okay. And so if this angle is smaller and these two are the same, that must make this angle bigger than this angle, right? We already knew that this angle was, I don't know, it doesn't matter, but I'm just going to say that I'm going to mark it as a different color. That'll be what I'll do. So we know that this is smaller than this. So to add up to 180, right? So I'll even put marks on here to show that they're different. But to add up to 180, right? Think about it if this was, we know that this is already smaller than this. So if this was, let's say this is 30, or let's say 40, right? This is 40, which means these two both have to be 70. So if this is bigger, let's say it's 60, then these have to both be 60. So in other words, because this is taking up more of the 180 of the triangle, this one right here, that means these angles have to be smaller. So this angle has to be smaller than that angle. And again, if that didn't make sense, I don't know, I thought I did a great job. All right, PSR and PQR. Okay. Well, we can already compare those because PSR is this angle and PQR is this angle. We know that these two are this angle Q is congruent to this one and angle S is congruent to this one. So because they're congruent to these, we can just sort of look at this relationship. So we know PSR is going to be less than, wait, did I put that backwards on the other one? Hold on. I may have just thought about that backwards. I said it right. I just think I did. So QPR is this top one. So we know this one is going to be bigger, is going to be greater than the other one. I just mixed them up. And so what they do in this other one, they say PSR and compare it to PQR. So PSR, this one is going to be smaller than this one. So what I really should have done at the beginning is sort of remark them now that I knew which one is bigger and smaller, and sort of just remark them with no more eraser, with the double dash, so I know that these are bigger than these, and so it'll be much easier to sort of tell. Okay, and again, I just marked them at the beginning, not sort of knowing what they're going to be asking. So there we go. Looks like 5.6 is done. I'll give you so much room in this; it's crazy. So yeah.